Kids, what's up? It's Professor Thomas. We are back again for some more medical math review under geometry. It's part 3 today. Today we'll deal with circles. As usual, quick review of what we'll do. Talk about the 4 key concepts for circles on ACT Math. 1, 2, 3, 4. Talk about each one. Then I will give you an opportunity to work with some problems. You'll go ahead and do the problem on your own. Come on back. We will go ahead and take a look at the answer and quick explanation. I am going to go over the most common things, highlight, give you some insight into what I have seen in the past 20 years of ACT preparation. Oh my goodness. Can't believe it's been that long. Number one, formulas. Kids, you got to know this stuff here. Put a star by this. Make sure that you understand this 100%. It's on your math review note card, 3x5 note card with all the important stuff for math. You're going to need to know the area. Area is A equals pi r squared, and circumference is C equals 2 pi r. Let's do a quick overview. Here we have a circle in the center. From the center to the outside here is going to be considered r, or the radius. From the center here all the way across, if we were to extend this out, here's the center. This is the diameter. So in relations, the radius and the diameter, the radius is half of the diameter. The outside is the circumference all the way around. Terminology, make sure you know. Number 2, we are going to be dealing with circumscribed and inscribed circles in regards to rectangles. So first of all, circumscribed. We are going to be given a square or a rectangle, and they are going to circumscribe a circle. They're going to tell you, go ahead and draw a circle around that and tell me how big that's going to be. They'll give you some information about the rectangle, and then you have to draw a circle around it. Maybe they'll give you this diagram already, and then you have to play around with it. Inscribed. So what they might do is they might give you a circle and tell you on the inside, go ahead and inscribe the largest rectangle that you can. It's the same thing. They're just going to switch them around. Number 3, percent ratios of circles. What they might do is they might give you a circle and then put another circle on the inside. And then they'll give you some information about one of the circles. And then you have to look at this from a perspective of pull them apart. You have a small circle and now a large circle, and you have to compare them. What's the percent ratio difference? They might give you the circumference, they might give you the radius, they might give you the diameter, they might give you the volume. Doesn't matter, it's basically the same thing, percent ratios. And number 4, length of an arc. Let's go ahead, clear the screen and draw a picture. Length of an arc. Here is our circle. Bit more terminology. Here is the radius at the center. And say they give us something that looks like this. Length of an arc is on the outside here, so they might give us the angle here. The angle is 30 degrees. And we need to find out the distance from here to here. They might give you the distance and you have to find the angle. It's the same thing, you just have to manipulate this around. Terminology, length of an arc. We do have 2 ways to do this. We have a formula that we could throw into our formula sheet here, and we have some kid logic stuff. So a couple ways we'll work with that in part number 4. For right now, let's go ahead, jump on in, get started with circumscribed and inscribed circles. Oh, one last note before we continue on. Some of these problems, there might be a diagram. Some of them might not have a diagram. I'd say the majority of them will have some kind of shape written out for you, but sometimes there'll be a problem that's just text. And part of the trick on this is to read this and draw a picture, as we learned some of the other videos here. So, okay, we need a circle, and the circle's radius is 4. So it's basically like that. So let's jump on in and take a look at number 2, circumscribed and inscribed circles and rectangles. Let's go ahead and take a look at the first problem. The problem we're going to work here is problem 38. What I'd like you to do, read this information, look at the diagram, come up with an answer. We're going to pause the video here. We'll come on back with the answer and explanation in a moment. For right now, go ahead, pause the video. Let's go ahead and take a look at the answer for problem 38. First things first, a square is circumscribed about a circle 7-foot radius, shown below. What is the area of the square? Notice I'm always circling and underlining stuff in here. So if you look over here, here is the trick on this. They give you the circle and then the square, and then they draw it kind of weird. I just redrew this line just like that. And when you get rid of this line and you see this one, you go, oh, well, that's pretty easy. Well, if it's 7 to the middle for the radius, the diameter would be 14, which means this is 14. How do you find the area of a square? Length times width is a formula we learned or had that memorized already. How easy is that? So 14 times 14 on your calculator is going to give you K for the answer. Let's go ahead and take a look at a trickier problem. Now, in this problem, problem 37, there is no diagram. So we're going to have to read this and then translate that into a picture. So the first thing we want to do is draw a picture and fill in the information from here. Go ahead, do that, come up with the answer. We'll take a look at it in a moment. For right now, go ahead, pause the video. Let's go ahead and take a look at the answer for 37. First things first, it says a square has sides that are the same length as the radius of a circle. So radius of a circle, same length. I underline all the important stuff so far. If the circle has an area of 36 pi square units, how long is the perimeter of the square? All right, let's weed through this. So first of all, it looks like we have a circle, and we're defining that circle. So we already have a circle. So let's go ahead and draw the circle. Okay, and put a dot in the middle. That will be the radius. And it tells us that this circle has an area of 36 pi. So right away, area and 36 pi, I know right away I have to convert over. Write my formula down first. A equals pi r squared. Write that down. Now, plug in the information from the problem. It says area is going to be pi r squared, so let's get rid of that. So it's 36 pi for the area. So we need to find out what r is. Well, pi is here and pi is here. So when you square r, you get 36. So all we really need to do is take 36 and just find the square root of that, because that's going to equal our r. Why? Because r squared equals 36 pi. So let's go ahead and do that. When we find out the square root of 36, we see that r equals 6. Now we can plug that in here. Here's what we do. We just draw that in, right? Okay. And I went both ways, right? Because this is 6. Why am I doing that? Because it tells us that we have a square. Now, if one length is the same, it's going to be 6. So we go 6 here for the radius. Now, to find the perimeter, it's going to be adding up all the sides. 6, 6, 6, 6. So 6 times 4 sides is 24, which will give us the correct answer of B, kids. The whole gist of this is taking this information and translating it into a picture. Once you have that picture, it's really quite easy, to be honest. Let's go ahead, take a look at the next problem. Let's go ahead, take a look at a third example using this concept here of inscribed and circumscribed. First things first, go ahead, read this problem, look at the diagram. You want to draw your own pictures, fill in the information accordingly, and then what we'll do is we'll come up with the answer. Pause the video here. We'll come on back with the answer and explanation in a moment. All right, let's take a look at the answer for problem 30. First things first, we're going to weed through this circle and underline key information here. It says, figure below shows two tangent circles such that 10 centimeters diameter for the small, okay, yep, got that, and it's already written in for us, we're good, is equal to the radius of the larger one. Okay, so the radius, you know, here on the larger one is going to equal 10. All right, I just wrote that in just in case. All right, and it says, what is the area, I circle that because that's what it's asking me about, of the shaded region. It's important that I make sure I understand the shaded region. Now, the first thing that we want to do here is we know that we have two circles. We have a small one, so I went over here and wrote small. And over here we have a larger one, so I put L for large, small and large. Let's go ahead and we're dealing with area, so right away I know A equals, first thing I do, pi r squared. I write it down. Pi r squared. Now let's go ahead, take our information and throw it into the formula. It says A, we know, is the area. Here the radius is going to be half the diameter, so it's going to be r is going to equal 5. So let's just plug that into the formula. A equals pi 5 squared, and 5 squared is going to give you 25 pi. Done. Let's go on to the larger circle. The larger circle, we know that r is 10 because it says here that we have this 10 centimeter diameter is equal to the radius right here. So we put our formula in here. It's A equals pi 10 squared. Pi 10 squared, and when we do that, 10 times 10 is 100, so 100 pi. All right, now remember the question is asking us, I put a circle around it. This is where kids make simple mistakes because they're going too fast. I highly suggest put a circle and underline stuff. So we need to find the shaded region. If you look here, this is a whole circle, which is the large. Here is the unshaded region. So we have to go 100 pi minus 25 pi. And when you do that, simple calculation tells you that's 75 pi, and that will give you the correct answer choice of K. Now, kids, listen. Couple things if you're non-shaded region, so that's something to keep in mind. ACT expects that to happen. Why? Because it's a time test, and 2, because kids want to rush through it. The third thing is this: in the math elevator, you see that the math elevator, we have 3 levels. Level 1, remember, is questions 1 through 20. These are so easy. Questions 1 through 20, you'll notice that very rarely in one of the math medical kits I'm going to give you anything from 1 through 20. It's so easy. So if you see yourself missing questions in level 1 math elevator, you need to do RCR right away, and Professor Thomas will guide you in that direction as well. So for right now, let's continue on here. Once again, 30 is K. We'll take a look at the next problem. Let's take a look at another problem. It's problem number 41. 41 is a word problem, so we are going to have to draw a picture. Go ahead, read, circle, underline all the important information. Draw your picture, answer the question. We'll pause the video here, come on back with the answer in a moment. Let's take a look at the answer for problem number 41. First thing we want to do over here is go ahead and circle, underline some important stuff in the question stem. I call this the question stem. It's the text. While viewing a satellite photograph, you noticed an almost perfectly round lake. Ooh, I don't see a lake here, so right away I draw one, almost perfectly round. Okay, and then it says from the scale of a photograph, the radius of the lake is about 200 meters. I circle that. Radius is to the center of the circle. I draw it in. R equals 200. Continue on. Among the following, which of the most reasonable estimates of the surface area in square meters of the lake. Right away when I see area, I write my formula down. Area equals pi r squared. Now I take this information here and simply plug it into the formula. We want to know the surface area, so let's calculate it. A equals pi 200 for the radius, which they give us, squared. Next thing we want to do is find out what 200 squared is. 200 squared is going to give you 40,000. So that means area equals pi 40,000. And you come over here and see that that leads us to answer choice D for 41, kids. The trick on this is they give you a lot of text. You need to weed through the text. It's not that hard. And then also you need to draw a quick picture. When you draw a picture, it just makes it so much easier. And finally, the last problem that we're going to work with here in this concept of circumscribed and inscribed is problem number 41. Remember, problem number 41 is a cluster problem, so you're going to be dealing with problems 39, 40, and 41. Here's the diagram that we have right here just above. So take a look and see what we have here, and if you need, read the information that's given above. For right now, go ahead, do that, pause the video, we'll come on back with the answer to problem 41 in a moment. Let's go ahead and take a look at the answer for problem number 41. Now, first things first before we get started with this problem, problem 41 is part of a cluster problem. I call them cluster problems. 41 is included with 40, 39, and it goes back and gives you the information that we need to deal with in this diagram here. Also, there's a little mini introductory paragraph that talks about this problem here. And you can see it's 39 through 41. Now, believe me, this is very easy for your eyes to skip over. I've even done it myself. I had one student come to me and say, hey, I can't answer problem number 40. I don't have enough information. I'm like, well, did you look above to see that it's a cluster problem? Oh. So be aware of that. Now, with that in mind, you see that I'm scrolling up and down, and that's kind of hurting my eyes, and it's annoying. So here's what we're going to do. We're going to look at this, and then I'm going to redraw this problem here. So they're asked, let's go back to the problem first. So here's the problem. It says, what is the radius in inches of the largest circle that can be drawn with no points of the circle outside of CFED? So let's go back and see CFED. That's right here. C to F is 100, F to E is 80, and E to D is there's no information given here, and there's no information here. So what I'm going to do, just for training purposes here, you wouldn't have to necessarily do this on test day. For me, I'm going to draw this out so I don't have to keep going up and down. So let's go ahead. Give me a chance to pull that red pen out, and I am going to draw that shape. So we've got C to F, and we said that that was 100. And then we have F going to E down here, and we said that that's 80. And then now we have E going to D. It's about like that. And let's go ahead and connect the dots. All right, so basically I just transcribed everything here. Now, we circle radius and we circle largest because those are the most important things. Now what we're going to do is most kids are going to want to start plugging stuff into the formula here. Let's just do a little bit of kid logic. We know that we have this shape right here. It's a four-sided shape. And what we want to do is we need a circle. So right away, I saw the trick on this. The trick is that you don't have something drawn out. They don't give you a circle. So let's just draw a circle. So here's our circle. Now we need to take this circle and put it inside that shape. But the problem is we can't have any of that circle hanging on the outside in any position. So we really don't even need a formula here, because we already know the radius of a circle, some quick review, is from the center to the outside, right? If we extend the radius, that becomes the diameter. That's really what we're looking for. So let's go ahead and start plugging our answer choices in. Here is what we have: 80 on one side, right? And 100 on the other. If we take answer choice E, which is a radius, right, of 80, that means that the diameter is 160. And if you take a circle with a diameter of 160 and try and fit it in there, it's going to be way too big. It's going to hang out way over to here. So that's way too big. With that in mind, you know that D is wrong as well, because the radius is 70, the diameter is going to be 140. We need to keep it within these constraints of 180. It's too big. Cross it out. Do the same concept here. 60 for the radius. The diameter is 120. That's still too big because it's going to hang out on both sides. You look at answer choice B, which many kids might have tried to do because of the formulas they tried to plug it into. If you take a radius of 50 and you find out that the diameter is going to be 100, it will fit. A diameter will fit in this side, but a diameter of 100 is going to stick out because this side here is only 80, so that is going to be too big. If you take a radius of 40, you see that the diameter would be 80. 80 would fit within 100, and 80 would barely fit within 80. It would look something probably like that. There'd be a little bit of space here. So the correct answer is going to be answer choice A. You see what I just did here? A little bit of kid logic. We didn't really need a formula. Basically, just draw pictures out, take this information, and then throw it into our pictures. Let's move on to core concept number 3. It is percent ratios of circles. Whoa, 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 whoa. Did I just say percent ratios of circles? I feel like I've done something like this before. Do you remember in section 2, circumscribed and inscribed problems, it was problem number 30? And problem number 30, look back in your booklet right now and see that we had that big shaded circle, and then we had the unshaded circle that was small, that was inscribed, and that unshaded circle had a diameter of 10. What we did with these problems is we pulled them apart and we said now we have a small circle and a large circle, and then we calculated the area for the small, calculated the area for the large, and then subtracted the small from the large to come up with the remainder. That's the same thing that you're going to see here, percent ratios. Basically, when you see the word ratios, that tells you that we have 2 circles. Keep that in mind as we go forward. We've already kind of touched onto the concept earlier. Let's go ahead and take a look at some more problems. Problem number 53. Let's go ahead and read this information here, and from all of the important stuff that we circle here, we're going to draw a couple of pictures over here from our diagram pictures that we just drew. Let's come up with the answer. Pause the video now. We'll come on back with the answer in a moment. Answer for problem number 53. 53 is a tricky problem, kids, so let's go ahead and take some time with this one. If the diameter of a circle is tripled, so we know we have diameter and we're going to triple it, the area of the resulting circle is how many times the area of the original. Okay, so right away I see original and I see tripled. So let's say that the original, we're going to call it original, or R-I-G, original. And then the tripled value, let's go ahead and call that new. Okay. All right. Now we have a diameter of an original circle. Professor, What are you talking about? I can't see that. So, if you're scratching your head like me, you know what you do? You use a little bit of kid logic. There is no diameter given for the original, so what's awesome about that is you just make it up. So, draw a circle and then put your stuff here, and then just say, all right, I'm going to make, how about 4? Diameter of 4. On my original. They don't tell us what it is. We just make it up. You could have said 6. You could have said 10. You could have said anything that you want. I just chose diameter equals 4. So I know it's easy for me to do a calculation that the R is going to be 2. All right. Once we have this information here, let's go ahead and do what? Triple it, kids. Let's go ahead and triple it. When you triple it, we are going to have a new circle, and the new circle's R is going to be 2 times 3 for the radius, right? Which is 6. And if the radius is 6, that means the diameter is going to be 12. How do we know that's right? If you say radius 2, radius 6, is that 3 times larger? Yes, it is. 4 for the diameter and 12. It's 3 times larger. So this is good information. All right. So now we have 2 circles that we drew in. We just did a little bit of kid logic. It just said when they don't give us information, just make it up. Now what we want to do is weed through here. What are we looking for? It says the resulting circle has the area how many times of the original. So area tells me right away, let's go ahead, write that formula down. Area equals A equals pi r squared. Pi r squared. Now what we do, take this information here, put it in there. So we know the radius is 2. So the area is pi 2 squared. Let's get rid of the square root. 2 times 2, or 2 squared, is 4. So it is going to be 4 pi. 4 pi is the original. Let's go ahead and see what happens to the new one when we triple it. We come over here. We're going to use the same formula. Area equals pi r squared. Pi. And we said that our r value is 2 times 3 times larger. It gives us 6. 6 pi. Area pi r squared. So let's get rid of the square. The area here is 6 squared, or 6 times 6. It's 36 pi. What does this represent, kids? This represents the new value, and the new value is the tripled value. You with me? Now, we have 36, and we have 4. So 36 divided by 4 gives us 9. And that will lead you to answer choice E. Let's take a look at one last problem in this subsection. It's problem number 47. Once again, read this, circle all the important information, have a quick look at your diagram, add to it if we need to, make sure you understand this, get an answer. We'll come on back with an answer and an explanation briefly. Let's have a look at the answer for problem number 47. Problem 47 reads, a circular swimming area has a diameter of 52 feet. The swimming area consists of a pool surrounded by a wooden deck of uniform width. The radius of the pool is 14 feet. What is the area of the wooden deck? Notice that as I'm going through here, I'm circling the things that are important. So right away, I come over here, have a look at what I just saw. I see a pool on the middle. I see another object here. I see that this is the wooden deck around the pool. Kind of unusual, but that's what they give us. Now, let's go ahead and get rid of that pi. So 14 squared, or 14 times 14 is 196, and let's throw that pi symbol on there as well. 196 pi. We move into the next one, the whole swimming area. We're going to have to subtract the pool from the whole area to get the area for the outside. Pretty common. So we come over here. Area is pi r squared. We are given the information that the diameter is 52 feet. That's all the way across. The radius will be half of that. So 52 divided by 2 gives you 26. So we know that the area for the whole swimming area is pi 26 squared. Let's get rid of the pi. Let's get rid of the square root. So it is 26 times 26 will give you 676 pi. That's for the whole area. That's what that number represents. We have the number for the pool, which is 196 pi, and the whole. So now, if we want to find out what this is, we subtract the middle. So 676 pi minus 196 pi is going to give us the difference, and that difference represents the deck. 676 minus 196 gives you 480. That will lead you to answer choice C. Kids, it's pretty straightforward. Subtract objects whenever they're superimposed like that. That's it for this particular subsection. We are going to go into the next area. Kids, we're on the home stretch. It's concept number 4. Let's go ahead and take a look at length of an arc. Let's draw a picture to get you up to speed. We have our normal circle. Here is the center of the radius. They are going to give you something that looks like this, and they could do a couple different things. They could give you the angle on the inside and then have you try and calculate what the length is on the outside, or they could give you the length and have you try and calculate the angle on the inside. A couple different things. We need a formula here, but I'm going to have you try and do this on your own without the formula. Once I give you the formula, it's a no-brainer. You just plug numbers in, but let's see if you can figure this out without the formula. Here's the problem. Take a look at problem number 50. Read, circle, underline all your information here, and then draw a diagram or picture down here to represent what you see. Make it as visual as possible. Try and answer this problem without the formula. Pause the video here, give it a go. We'll come on back with the explanations and that formula. So kids, what do you think of that problem without the secret formula? What I'd like you to do now is take a look at this formula, see if this helps us out. Ready? Boom. Length of an arc equals n over 360 times 2 pi r. By now, when you see 2 pi r, you should just say that's the circumference. In this problem, they gave us the circumference, so look at how easy that is. We just take our number, throw it in there, divide it out, multiply it by the circumference. Let's go ahead and take a look at the answer. Let's take a look at the answer for problem number 50. 50 says, what is the length in inches of a 144-degree arc of a circle whose circumference is 60? Our formula, remember, is n over 360 times 2 pi r. This is the circumference. How easy is that? You just plug that in, get rid of all that, and that turns out to be 60. Other derivations of this, they could give you the area, and then you could figure out, or they could give you the radius, and then you could figure out the circumference. Over here, n is going to be 144, so let's just pop that down over here. N is the degrees they give you, 144 over 360. And it's a simple calculation. 144 divided by 360 times 60 is going to give you the answer choice of 24. How easy is that once you have the formula? H, kids. Let's try another one. Kids, let's take a look at one final problem using length of an arc, and this will be it. We're going to do this two ways. First of all, I want you to read, circle, underline everything, look at your diagram, answer this question, use that formula that we had, and then we'll come on back with the answers and explanations, and then I am going to briefly touch on something called the magic paper ruler. So go ahead, pause the video here, work on this problem. We'll come on back with double explanation on this one. Let's take a look at the answer. We'll do this two ways. The first way is just the regular way with that formula. It says in the circle below, the radius OA has a length of 10 meters. Circle it. And the center angle is 30. What is the length of arc AB? All right, so we just take that information, quickly look over. We have a diagram. Pretty straightforward. Formula N over 360 times 2 pi r, and we remember that 2 pi r is really the circumference. So what do? We plug our information in. Here is the radius, so we can start over here. We could say 2 pi 10, and our arc n value is going to be 30, so it is 30 over 360, and then you just plug this in on your calculator and crunch out an answer. And when you do that, you're going to come up with 5.23. Now, when you come over here, I don't see 5.23, so what we do is on your calculator, simply go in here and translate your answer choices. That's what I did. And when you do that, translate your answer choices in all of them unless they look like really weird. Like, for example, we're looking for 5. I got a circle around that. And I look at K. K says 30 pi. Well, 30 pi is 94.2. It's 30 times 3.14. 3 times 3 is 9, so it's going to be 90 something. All right, so that one's way too big. 10 pi is going to be 31.4, so that's way too big. Over here, now let's start calculating these out. 5 pi divided by 6 for h is going to give you 2.62. G is going to give you 10.46. Too big, too small. And F gives you the exact number, 5.23. Just translate your answer choices. You saw that I started with the bottom one because I quickly could cross these two out right away. And then you could skip around and do whatever ones that you want. So the formula makes this problem extremely easy. Now, as I mentioned earlier in the video, I'm going to teach you some creative problem-solving strategies we can have in our back pocket for answering questions that we're actually absolutely no idea. And this problem, number 60, is one of the harder ones at the end of the test. Let's say that you forgot that formula and now you're sitting here scratching your head. We can use a little bit of creative problem-solving strategies. One of the techniques here is called KidLogic Magic Paper Ruler. And the Magic Paper Ruler says a couple things here. Here is, first of all, your ACT booklet, and then we have our bubble sheet here. And on our bubble sheet, we've got A, B, all the bubbles and stuff like that. What we can do is take the side of the bubble sheet and lightly right on the side, bring that bubble sheet over here, and make a ruler, set it up here, and make a ruler. So here we have 10. The edge is 0. Half of that is 5. And half of that is 2.5. Then we just take our paper and then just simply measure from A to B and then kind of jimmy it around. It looks like we would use this part here. So if you see we have that amount of space there, it's probably going to go from here to about here. Right? There to there. And then from here to here, that looks like it's maybe just a hair larger than 5. 5.1, 5.2, 5.0, 5.3. It's gonna 4.9, kids. then what you'd want to do is translate your answer choices and see which one is going to be the closest. Remember, let me write these down so you see this. This is super important. 5.23 for F. G was 10. 10.46 or 10.5 about. H was 2.6. This is way too small. This is 31.4. Way too big, and 30 pi is like 94. So do you see what happens here? The magic ruler works because the answers are so spread out. So keep this in mind. Professor Thomas will go over a small little workout and lecture on the magic paper ruler. It's a nice little method to keep in your back pocket, A, if you're running out of time, and B, if you forgot a formula. For right now, please copy that formula down, n over 360 times 2 pi r, or the circumference. That's it for all the problems. Let's go back in and do a quick review of everything that you should have gotten out of this lesson. All right, kids, we are on the home stretch. Let's go ahead and do a quick blazing lightning speed overview of everything you should have gotten out of the medical kit geometry math section dealing with circles. There's 4 key concepts here that we want to work with here. Number 1, we're going to need formulas. Here they are. Ready? Area, we're going to need to know that. Circumference, we'll need to know that. And length of an arc, we'll need to know that. When you go in and start working with geometry problems and you see anything that's circular, start thinking, what formula am I going to calculate? Whatever they're asking us for, the area, the size of this, the size of that. Pull them apart. That would go for circumscribed as well. Length of an arc, pretty straightforward. It's just a memorization of that formula. Or what we can do is we can use a little bit of magic paper ruler, creative problem-solving strategies using the side of your bubble sheet. Kids, that's it. It is done. Circles, part 3, geometry. Thanks for watching. We'll see you in the next video. Bye for now.